Hello, Honors Algebra 2. We are going to talk about the Edgenuity section 8.6 called Multiplying Radicals. There is only one objective to this. It is to perform multiplication of radical expressions. So let's talk about that. Let's do some problems. So throughout this unit, you've learned that you can do things with the radicals and with the so-called radical form like this. The radical is the root symbol. That symbol right there is what they call the radical symbol. We also learned that radicals can be written in exponent form, that roots are just fractional exponents. And a lot of what I'm going to do today is going to deal with that, especially with the variable part. So notice that we've got all multiplication here. We've got 2 times x cubed. We've got 18 times x to the 5th inside these square roots. So the first thing that I'm going to do is write them as individual square roots, because you can always split up multiplication inside the roots as individual multiplication of the roots. So we'll have the square root of 2 times the square root of x to the 3rd times the square root of 18 times the square root of x to the 5th. And what I'm going to do is I'm going to put the numbers together inside of one square root, so 2 times 18. And then I'm going to do the same thing with the variables, but I'm looking towards the idea of writing the variables with fractional exponents rather than roots. So here we got square root of 2 times 18, which is 36. Well, that's going to come out super convenient, right? Times the square root of x to the 8th, because remember, when I do x to the 3rd times x to the 5th, that's x to the 3 plus 5. When you have the same base, you add the exponents. So just a little reminder about that. And then the square root of 36 is 6, because 6 squared is 36. And I want to write this as a fractional exponent. That'll be x to the square root means the bottom of the fraction is a 2, and the exponent tells you the top of the fraction. So that's 6 times x to the 8 over 2, but 8 divided by 2 is 4, so this is 6 times x to the 4th. I'll give you a chance to look at that, and then we'll do part B. All right, so in part B, now we've got cube roots, right? But I'm going to do the same thing. I'm going to split up the numbers and the variables and put things back together and see what we have. So that'll be the cube root of 9 times the cube root of x to the 4th times the cube root of 3 times the cube root of x to the 8th, which now I can take the number parts and combine them back together. So that'll be the cube root of 9 times 3 times the cube root, and I can do the same with the variables, x to the 4th times x to the 8th. So that's the cube root of 27. 9 times 3 is 27. times the cube root of x to the 4th times x to the 8th. And remember again, if I'm doing the same base, I add the exponents. So 4 plus 8 is 12. So this will be x to the 12th power. And the cube root of 27, so that asks the question, what number did I cube to get 27? And the answer is 3. 3 cubed is 27. You can also see that here. 9 is 3 times 3, so you have 3 times 3 times 3. That is 3 of them. So 3 cubed. So the cube root of 27 is 3 times, and let's turn this into a fractional exponent. There's the bottom, there's the top. So this is x to the 12 over 3. So that's 3. And then 12 divided by 3 is 4, so this is times x to the 4th. Now, don't take away from this. The fact that we got x to the 4th twice is just a coincidence. Has nothing to do with math going on, okay? So just be aware of that. I'll give you a chance to look at that. And let's move on to the next problem, or the next set of problems. So here we've got some stuff outside of the square roots, some stuff inside of the square roots, and how we're going to multiply all this. Well, again, it's all just multiplication. This is 2 times that square root, and times -3 times that square root. So if I remember that it's all multiplication, then I can write that multiplication in any order that I want. So I could write this as 2 times -3 times the square root of 5x cubed times the square root of 10x squared. So then 2 times -3 is -6. And then I can combine all this. That's times the square root of 5 times 10 is 50, and x to the 3rd times x to the 2nd is x to the 5th. So then that's -6 times the square root of 50 times the square root of x to the 5th. So that's we got to figure out what to do with this 50, and we'll explore that. Actually, why don't we just explore it right now? So let's break down, let's factor 50 into a factor tree. It's 5 times 10. 10 is 2 times 5. So a 5 squared there. So it's 2 times 5 squared. So let's call it -6 times the square root of 2 times the square root of 5 squared times, and what we'll do, let me get rid of this so I have the room there. So the x to the 5th, how are we going to deal with that? We could write that as a fractional exponent. And if I do that, it'll be x to the 5, to the 5 over 2 power. And I could leave it that way. It is perfectly okay and perfectly acceptable to leave it that way. But I could do things with it too. And we'll explore that as we go. But first, the square root of 5 squared, square roots cancel squares, so that answer is 5. So this is -6 times 5 times the square root of 2 times, so if I look at this 5 over 2, if you were to turn it into a mixed number, which I rarely do, but if I were to do 5 divided by 2, that would be 2, which would give me 4, which would give me a remainder of 1, or in other words, 2.5, right? And I could write this as x to the 2.5 power. Now, how does that help me? Well, it helps me because what 2.5 means is 2 plus 1/2. So if I think of it as, if I think of it as 2 plus 1/2 instead. Okay, so 2 plus 1/2. Here's what I can do with that. -6 times 5 is -30. So I'm taking care of this first, right? Times the square root of 2 times. Now, when you're adding exponents, what it means is that you had the same base multiplied with those two exponents. So this can be seen as x to the second times x to the 1/2. And that would get me this. Well, it would get me that, right? So that is helpful because now I have a square root of x again, right? So I can put this -30 with the x squared. So -30 x squared times the square root of 2 times, and I can turn this back into a square root, from x to the 1/2 back to the square root of x, and then I can put these two square roots back together. A clever little trick there. So -30 times x to the second times the square root of 2x. Now, that's not the only way I could have done that. I could have done this strictly, I could have taken care of this x to the 5th strictly inside of the square root. And that would have been a decent way to go too, because I could have thought of it as many x squareds as I could get. So it would have been x squared times x, and so square root of x squared is x, square root of x squared is x, times square root of x, which I can't do anything with, and then that gets me the x squared times the square root of x. So that's perfectly okay way to do it also. I'm just trying to remind you that you can play around with these fractional exponents. Okay? So let's do this problem here. Let's do problem B. And now we've got cube roots again, and again we've got all multiplications, so let's break everything down into multiplication. So that is the cube root of 2, cut that off a little more, times the cube root of x to the 5th times the cube root of 64 times the cube root of x to the 9th, which is, so let's look at cube root of 2 times 64. 2 times 64 is 128. That doesn't really help me a lot, and I don't like that very much. So instead of calling it that, let's call it 2 times 64. But 64 is, let's break down 64. Let's look at 64. That's 2 times 32, which is 2 times 16, which is 2 times 8, which is 2 times 4, which is 2 times 2. So 64 is 1, 2, 3, 4, 5, 6 2's multiplied together. So it's 2 to the 6th. So let's call it 2 times 2 to the 6th instead. And then we'll see how we can deal with that. That's a little bit nicer to deal with. I probably should have just left it, left them separate. But I might, what I'm saying is I might split them apart again because it'll make my life a little bit easier. So then the cube root of x to the 5th times, now look at this one. If I turn this one into a fraction, into a fractional exponent, it'll be x to the 9 divided by 3, which is a nice, neat number. It's x to the 3rd, right? 9 divided by 3 is 3. So I'm going to do that just to have something that makes my life a little bit easier immediately. Okay? So here, I'm going to do sort of the same thing. Cube root of 2 times, keep making that radical symbol a little bit too long, times the cube root of 2 to the 6th. And I'm actually going to turn that into a fractional exponent when I get a chance. This one, I'm going to split up into, instead of x to the 5th, we're going to call it x to the 3rd times x to the 2nd. That's 5 x's. Times, and then I'm going to write this as x to the 3rd. That is to say 9 divided by 3 is 3. So why did I do that? Well, because now I've got cube root of 2, which nothing I can do with that. If I write this as a fractional exponent, that's 2 to the 6th divided by 3, and all of a sudden that's an easy problem, right? And then cube roots cancel cubes. So this part becomes just x, and then I've got times the cube root of x to the 2nd, this part is still left over, times x to the 3rd. So now, let me start dealing with everything that I've got here. I've got 6 divided by 3, which is 2, so this is 2 to the 2nd. I've got an x times an x to the 3rd, so that's x to the 4th. So I've taken care of that, I've taken care of that, I've taken care of that. And then I've got cube root of 2 and cube root of x squared, which I can put together inside of a cube root and call it the cube root of 2x squared. So then, all I'm left to do is sort of just clean things up. 2 to the 2nd is 4 times x to the 4th times the cube root of 2x squared. And there we have it. I'll pause for a moment. Let's get a look at that. All right, let's move on to the next problem. Here we've only got one problem, and this is a matter of distribution, right? So I'm going to do a couple of things. We're going to wind up distributing this, but before we do that, I want to write it a little more carefully. I don't like minuses. I prefer plus negatives because it helps me keep track of what's positive and what's negative. So instead of square root of 8x squared minus, I'm going to write plus negative 2 times square root of x. Okay? And then I'm going to distribute the square root of 5x. Now, I could simplify this first, it doesn't really matter that much. You could say, okay, well, that is going to simplify, and you're going to be able to pull a square out of that. And I suppose we could do that first if we wanted to, and it is perfectly okay to do that first. But I'm not going to this time. Okay, maybe on a different one. So we'll have the square root of, remember, a square root times a square root is still a square root. It's just all the stuff put inside of it multiplied together. So let's say 5 times 8 is 40 times x squared, but the square root's going to cancel the x squared, so I'm going to leave it as x times x squared, right? That'll be helpful. Plus negative. Now, this negative 2 has nothing to multiply with, so it just stays out there in the front. So the negative 2 times the square root of, and 5 times x, which is 5 times x squared will be more helpful than x times x, right? So then we got to clean things up a little bit. Let me explore 40 with a factor tree. That's 5 times 8, which is 2 times 4. There's a square that I can use, right? So let's call it, instead of calling it 40, let's call it 2 times 4 times 5. And let's leave the variables out of that part, and we'll explore the variables by themselves. It would be more useful to just leave this square root of x, and then times the square root of x squared is just x without any square root, right? Plus negative 2 times the square root of 5 times the square root of x squared, which is just x. So now square root of 4 is 2, so I'll pull that 2 out, times the square root of 2 times 5, which I can't do anything with, so I'll just multiply them back together and get 10, times square root of x times x, plus negative 2 times x will be negative 2x times the square root of 5, and so we'll have that equals, let's put these square roots back together, and let's reorder this so that those two are together. So it'll be 2x times the square root of 10x plus negative 2x times the square root of 5. And that's as good as any other. Now, there's other ways you can change that plus negative to a minus, things like that. But there's no other good way to combine it, because notice that the radicals are not like terms. One is 10x, one is 5 inside of the root, the radical symbol. And because of that, we can't put these together any more than we have. The only other thing that you could really do is maybe you'd see this 2x and a 2x, and you'd say, well, I can factor 2x out of it, and then you could have another thing to distribute, but why would you distribute when it asks you to put together? So I'll give you a moment to look at that. And let's go on to the next question. All right, let's talk about a bigger distribution here. It's got a minus again, so I'm going to want to write the whole thing with plus negative. So 4x times the cube root of 4x squared times 2 times the cube root of 32x squared plus negative x times the cube root of 2x. And I was more careful to write dots in the multiplication inside so that you don't confuse the cube root with cubing the two, things like that. I wanted to separate them a little more because it gets hard to read, right? So let's do this distribution then. 4x times 2, that would be 8x, times this cube root times this cube root, and we could combine all that. So times the cube root of 4 times 32, which, let's talk about all that together as a, let's call 4 2 to the second, and 32 is actually a power of 2 also, right? It's 2 times 16, which is 2 times 8, which is 2 times 4, which is 2 times 2, and there's 1, 2, 3, 4, 5 there. So instead of writing 32, I'm going to call it 2 to the 5th. And I'll start exploring how many versions of 2 to the 3rd I can take out of that. And then x squared times x squared winds up being x to the 4th, and I'll have to explore how many x to the 3rds I can take out of that as well. Let me get rid of that breakdown just so I have some room here. Plus, positive times negative is negative, and 4x times x is 4x squared times the cube root of 2 squared times 2 times x squared times x, which is x to the 3rd, which is going to be convenient. That whole thing is convenient, you can probably see. So then we've got 8x times the cube root of, so if we combine 2 to the 2nd and 2 to the 5th, we have 2 to the 7th, right? So we have 7 2's all together. And so having 7 2's, what I would like to do is break it down into as many groups of 3 2's as I can. So if I have 7 of them, that's 2 to the 3rd, 2 to the 3rd, times 2 to the 3rd, again, that's 6 of them, but I have 7 2's all together, so I'm going to add another, just put another 2 in there, just to make sure that I have all 7 of them, right? And then x to the 4th, I don't really want to look at as x to the 4th, I want to look at it as x to the 3rd times x, so that I'll be able to cancel out an x to the 3rd with the cube root, right? So then plus negative 4x squared times, and this one's going to be even easier, right? The cube root of, and 2 squared times 2 is 2 to the 3rd. That's 3 2's all together, times x to the 3rd. So that'll come out really nice, right? So let's get everything cleaned up here. Cube root of 2 cubed, cube root of 2 cubed, that's 2 times 2. Cube root of x cubed is x. So I've got all that, and then I've still got some stuff inside this cube root. So I've taken care of that, that, and that inside the cube root. And I've still got this 2 times x that has to stay inside of that cube root. Plus negative 4x squared times cube root of 2 cubed is 2, and cube root of x cubed is x, and I've got no cube root there at all. So that turned out real nice on that end. So now I've got to do 8 times 2 times 2, or 8 times 4 if you prefer, which is 32. And x times another x is x squared, x to the second, times that cube root of 2x, plus negative 4 times 2. Negative times positive is negative. 4 times 2 is 8. And then x squared times x is x to the third. X squared times x right there. And there we have our answer. Now, if you really wanted to, you could turn that plus negative back into a minus, but that top answer is a perfectly acceptable answer as well. I'll pause for a moment, give you a chance to look at that. And I'll let you look at that for just a moment. All right, let's move on to the next problem. And so our next problem is a full distribution problem. So what I mean by that is, okay, so we've got this square root of 10 plus 2 times square root of 8, and we're going to take that whole thing and multiply it by square root of 10 minus or plus negative 2 times the square root of 8. And what we're going to do is we're going to take this one and sort of treat it as an individual entity, okay? And we're going to take that as a whole one and distribute it to these two things. So what we're going to do is we're going to get square root of 10, which is that square root of 10, times this whole big thing over here. So times square root of 10 plus negative 2 times square root of 8, plus that plus right there, 2 times square root of 8, that 2 times square root of 8, times, again, the square root of 10 plus negative 2 times square root of 8. And then we'll be able to distribute that way. And then the problem gets a lot easier. A lot of people like to use FOIL here. I am not a fan of FOIL. It's a one-trick pony that I don't think does you as much good as learning how to do this procedure of distributing. Okay? So, square root of 10 times square root of 10 is the square root of 10 times 10, which is 10 squared, plus negative 2 times the square root of 10 times 8, which is 80, plus 2 times square root of 8 times 10, which is 80, plus 2 times negative 2 is negative 4, times the square root of 8 times 8, which is 8 squared. I'll give you a second to look at that. I'll be right back. Sorry about that. I had to let my dogs back in. All right. So now, notice here in the middle of this, that we have like terms that we can add together. Okay? And we have -2 plus +2. So that's actually going to cancel each other out, right? That's going to make 0, which is awesome. So we can actually like ignore these because they create 0. And square root of 10 squared is just 10. That's the reason that I wrote it that way. Plus -4 times square root of 8 squared, which is 8. Gives us 10 plus -4 times 8, which is 32. And 10 plus -32 is, you got to subtract the two numbers and go with the sign of the bigger one. So the bigger one is negative, so it'll be negative, and then 32 minus 10 is 22. So we get -22. Now, you might have recognized this up here as a difference of squares, and if you had, an alternate way to do this problem would be to say, okay, that's the first one squared minus the second part squared, which square root of 10 squared is 10, minus this squared goes to both of them, so 2 squared, which is 4, times square root of 8 squared, which is 8, which still gets you, of course, 10 minus 32, which is -22. But I wanted to show you the whole procedure because some people recognize difference of squares and some people don't, so I didn't want to presume that you could recognize a difference of squares. But if you did, good for you, and that's how you would do it if you could just see the difference of squares. I'll give you a moment to look at that. And let's move on to the next one. Here's another distribution problem. So again, I'm going to take this, distribute it to both of these. So that'll be the square root of 2x cubed times 2 times 10 times x to the 5th inside the square root, plus the square root of 6x squared plus the square root of 12x times 2 times square root of 10x to the 5th plus square root of 6x squared. And you should be noticing that there is some simplification that could be done, and you could do it before, you can do it after. What I'm going to do is say I'm going to do it afterwards because I might get a bunch of things that come together and make things real nice. Okay? So let me do the distribution here, the distribution here. And so the 2 has nothing else to go with it, so it's just 2 times the square root of all this stuff multiplied together. So 2 times 10 is 20, and I'll re-break that apart later. And x to the 3rd times x to the 5th is x to the 3 plus 5, so that's x to the 8th. And as you might be able to see, hopefully you can see, that x to the 8th I'm going to be able to write as a fractional exponent, and that will give me a real nice, neat answer, because I'll just do 8 divided by 2, right? Plus the square root of 2 times 6 is 12, and x to the 3rd times x to the 2nd is x to the 3 plus 2, or x to the 5th. So there's that part. Plus, we have this 2 out here that'll just stay out there for now, times the square root of, and let's multiply everything together. 12 times 10 is 120. We'll break that down and worry about that later. Times x to the 5th, that's x to the 1 plus 5, or x to the 6th plus the square root of 12 times 6 is 72, and x times x to the 2nd is x to the 1 plus 2, or x to the 3rd. So then let's start trying to figure some of this stuff out, break it down even more. So we've got 2 times the square root of 20. Let's break down 20 and see what we have there. That's 2 times 10, which is 2 times 5. So that's 2 squared times 5, right? So I'm going to break that down in here. Instead of writing the square root of 20, I'm going to write the square root of 2 squared times the square root of 5. And then I'm going to write this square root of x to the 8th as x to the 8 over 2. Remember, this is the top, and what the root is tells you the bottom of the fraction. Okay? Plus. So there's just this first one broken down as much as I can so I have lots to look at. Plus, let's look at 12. 12 is 3 times 4, and 4 is 2 squared. So let me call the 12, let me call that square root of 3 times square root of 2 squared. And then let me look at x to the 5th. Let me break it down into several x squareds. X squared, that's 2 of them. X squared again, that's 2 more, and then I need a single x. Right? I'm going to have to squeeze things in here because I'm going to run out of room if I don't. Plus 2 times the square root of, how does 120 break down? Well, it's 12 times 10. 12 is 3 times 4, which is 2 times 2. 10 is 2 times 5. So what do we have there? We want to take out all the squareds that we can, so it's 2 squared times another 2 times 3 times 5. So it would help us to look at it that way. Times square root of x to the 6th is the same as x to the 6 over 2. That will help me out. Plus square root of 72. Let's figure out how to break down 72. 72 is 2 times 36, right? Well, that's helpful because 36 is a perfect square. So let's call it square root of 2 times square root of 36. Oh, and then I got to squeeze it in here. Square root of, I'll just call it x cubed for now, and we'll handle it in a moment. But we're going to call x cubed x squared times x, right? Notice that I'm using the fractional exponents when they're convenient, and I'm using the roots when they're convenient, right? So that's something that's important to do, is to recognize when you can use certain versions of something to make your life a little bit easier. So we've got 2 times the square root of 2 squared is 2 times the square root of 5 times x raised to the 8 over 2, but 8 divided by 2 is 4. Remember, fractions can be viewed as division problems. Plus the square root of 3 times square root of 2 squared is 2, because square roots and squares cancel each other. And then I've got a square root of x squared, another square root of x squared, so those square roots are going to cancel the squares and leave me with x times x. And then I've got the lonely little square root of x there. He's got to stay inside the square root because he's all by himself. And then plus, so we've got a square root of 2 squared there. And then I'll just put all this back together inside the square root. So it's going to be 2 times 2, because square root cancels the square, times the square root of 2 times 3 is 6, 6 times 5 is 30, so I may as well multiply, excuse me, all that back together. Times x to the 6 over 2, but 6 divided by 2 is 3, so x to the third, plus square root of 2 times the square root of 36, which is 6, times the square root of x cubed, which I'm going to call x squared times x now. And that'll help me break it down as I go. So now we've got 2 times 2 is 4, times x to the fourth, times the square root of 5. So I'm done with all of that. Plus 2 times x, that's 2 times x squared, and then I have this square root of 3 and square root of x that I can put together inside of a square root and call square root of 3x. So taking care of all that. Plus 2 times 2 is 4, times x to the third, times square root of 30. So taking care of all that. Plus, I've got 6, and then I've got square root of x squared is just x. And then I'm going to have square root of 2 and square root of x that I can put together. So times square root of 2 times x, or just 2x. And as you can see, if you look at this, there are no like terms and no like radicals, nothing to put together. So this winds up being my final answer. I'll give you a moment to look at that. And we are on to our final problem. So let's talk about simplifying this using exponents and using radicals. So I've been doing combinations of each. So let me take this problem and really break it down. So let's do exponents first. So this will be the exponents one right here. This is x to the 1, because you don't see anything there, so it's x to the first, to the 1 over 6 power, times y to the 3 over 4 power. That's an awful 3 over 4 power. And that's the most I can do with it for exponents, right? There's really no point in trying to put it together any more than that. Now, what about in radical form? What could I do in radical form? Well, not much is the answer. I've got different roots. And so what would I do in radical form? What you cannot do, you have to be really careful about this, is you can't just put it all under one root, because you've got different types of roots, right? So there's not a whole lot you can do with this other than to just keep it as is. You've got the 6th root of x times the 4th root of y. Now maybe you could put the parentheses there and put the cube there instead, but there's not a whole lot left to do with this. All right, I'll give you a chance to look at that. And that is our last problem of the section. So thank you, everyone.